So we discussed today about the motion of a projectile. Any object which is thrown in air and it follows a path, and the entire path or the entire motion of that body, if it is controlled by gravity, then that motion of a body might be called as a projectile motion. So we can say that an object in flight through air and its motion being controlled by gravity is the motion of a projectile. So we will realize the motion of a projectile as a two-dimensional motion, because the object has been thrown in air and it follows a specific path, it follows a specific curved path, and as such the motion can be called as a two-dimensional motion. So various examples of projectile motion is, suppose a football is kicked in air, it follows a path that is called as a projectile motion. A cricket ball which is thrown in air by a fielder, it is also a projectile motion. A javelin thrown in air follows a path that is also called as the path of a projectile or projectile motion. So variety of examples we can get in nature that describes the motion of a projectile. But our basic assumption while describing projectile motion is that the entire motion of the projectile is controlled by the gravitational pull of the earth only. We neglect other forces such as air resistance or the viscous drag of the air and any other retarding force. So we will only consider that the motion of the projectile is totally controlled by gravity. So we can say that an object in flight through air, an object in flight through air, and whose motion is controlled by gravity, is controlled by gravity only. The gravitational pull of the earth only controls this motion, is controlled by gravity, is a projectile. Is a projectile. Many examples we will come across. A packet dropped from an aeroplane, a packet dropped from an aeroplane. It will follow a path that will be called as the path of the projectile. A javelin thrown in air, a javelin thrown in air, and suppose a football kicked in air, and many such examples. Kicked in air. So with respect to a packet being dropped from an aeroplane, this might be the path followed by the packet. The aeroplane is moving in a specific direction, and while moving it has dropped a packet that will reach the earth's surface following this type of path. It has been dropped from a specific height and it follows this type of path until it reaches the earth's surface. So this is also called as a path of a projectile. A javelin which is thrown in air or a football which has been kicked in air might follow this type of path, and that also is the path of a projectile. So we'll analyze the motion of the projectile as a two-dimensional motion. So this projectile motion is necessarily a two-dimensional motion, and we will analyze the two-dimensional motion as two different one-dimensional motion along two different directions. We all know the equations of one-dimensional motion. So when we describe a two-dimensional motion, we will analyze that two-dimensional motion as two independent one-dimensional motion along a horizontal direction and along a vertical direction. And we will use the same equations that we frequently use for representing one-dimensional motion. So this was the direction in which the object was thrown, and it follows this type of path. This is the direction in which the object is thrown when it follows this type of path. So the object has to be projected or thrown with a definite velocity. Then only either this type of path or this type of path will be followed by the object, and we will call this projectile. So let us analyze both these types of path that a projectile will follow. So let us start with the first situation. For example, a packet which has been dropped by aeroplane. Even you can say that a bomb which has been dropped from aeroplane will follow the path of a projectile. So let us call that as a horizontal projectile, because initially the motion of the object is along the horizontal direction. So let us call that projectile as a horizontal projectile. So suppose with respect to the surface of the earth, the object has been thrown in the horizontal direction with a certain velocity. The object has been thrown in the horizontal direction with a certain velocity, and let that velocity be u vector. So it might follow this type of curved path until it reaches the ground. So we consider two independent axes, that is the x-axis along the horizontal direction and the y-axis along the vertical downward direction. Suppose this is the positive direction of the y-axis and this is the positive direction of the x-axis. The point from which the object has been thrown with a constant velocity is called as the point of projection. So this point O is called as the point of projection. Suppose at any instant of time, the position of the object or the projectile is suppose the point P having coordinates x and y. So this point P is called as the instantaneous position. Instantaneous position. That means position at any instant of time t. That is position at any time t. That means this object has followed a path, a curved path, and you can say that it has traveled a horizontal distance x and a vertical distance y. So this distance is obviously x and this distance is obviously y. So if I name this point as point M and this point as N, then ON is also x and OM is also y. So now, though this path is a curved one and the motion is a two-dimensional motion, we shall analyze it with respect to two independent one-dimensional motion, one along the horizontal direction and one along the vertical direction. So because I have already told that the motion of the projectile is purely controlled by gravity, so the force that is acting on the projectile is the force of gravity that is acting vertically downwards. So that means along the vertical direction, in the vertical downward direction, there is the force of gravity, whereas there is no force along the horizontal direction. As there is no force along the horizontal direction, that motion is uniform motion. So motion along horizontal direction is uniform motion. Motion along horizontal direction is uniform because there is no force acting along that direction. So in time t, if it has traveled distance x, so in that case we can write distance equal to speed into time, because there is no force, there is no acceleration along that direction, it is moving with a constant velocity along that direction. And motion along the vertical is controlled by gravity. Motion along vertical is controlled by gravity, and so it is accelerated motion. So it is an accelerated motion, and the acceleration is obviously the acceleration due to gravity g that is acting vertically downwards. So in time t you can say that it has descended a distance y in the vertically downward direction, and so we can write y equal to half gt square. Remember that there is no initial velocity in the vertically downward direction. That's why this becomes y equal to half gt square. So now from equation 1 and 2, if we eliminate t, we can write y equal to half g. Instead of t, we will write x by u. So this becomes x square by u square. So finally, what we get is this is from 1, or using 1 you can say. So y equal to half g x square by u square. So this equation is y equal to, if you see that g, u are all constants. So g by 2 u square is a constant times of x square. Now this equation is a quadratic equation in x and a linear equation in terms of y. That means the power of x is 2 where the power of y is 1. And this type of equation is the equation of a parabola, and as such we can say that the motion of the projectile is parabolic in nature. So this equation is the equation of a parabola. And we say that the trajectory or the path followed by the projectile is parabolic in nature. We say that trajectory of a projectile is parabolic. Trajectory of a projectile is parabolic. Or we can also say that the locus of the projectile is parabolic. So this is a brief description of the horizontal projectile. So if you want to calculate the instantaneous velocity, that means the velocity of the projectile at the point P, that we can also do. So the velocity will have again two components. So at the point P, there is a horizontal velocity and there is a vertical velocity. So this horizontal velocity is suppose Vx and the vertical velocity is suppose Vy. That means at any point on a curved path, the velocity is always tangential. So the velocity V at the point P having coordinates x and y, it has two components. So you can write V vector as having a x component Vx I hat and Vy j hat, where Vx is obviously u because along the horizontal there is no force. So along the horizontal the motion is purely uniform. So Vx is u, but Vy is gt. If you know the equation V equal to u plus at, the initial velocity along the vertical direction is 0. There was no velocity along the vertical direction. So Vy is just gt, as the acceleration along the vertical is g. So therefore you can say V is equal to Vx square plus Vy square. It is u square plus g square t square square root. So that is the instantaneous velocity of the projectile at any time t. And if you want to know the direction, let me consider that this v vector makes an angle alpha with the horizontal direction. So we can write tan alpha is equal to Vy by Vx, so that the angle made by the velocity vector with the horizontal is tan inverse of Vy is gt and Vx is u. So that will be the angle made by the velocity vector, and this will be the magnitude of the velocity vector. So this is a simple description of the projectile motion, the horizontal projectile. Now we shall consider the oblique projectile. That means suppose a javelin is thrown in air or a football is kicked in air. That type of motion, that type of projectile motion might be called as oblique projectile. So we proceed with the oblique projectile now. So in case of oblique projectile, the projectile is thrown with an initial velocity, and suppose it follows this type of path. Its initial velocity is tangential to the curved path. From suppose this point, the projectile has been thrown with the velocity say u vector, making an angle theta with the horizontal, and it follows this type of path. So that means the javelin which has been thrown making an angle theta with the horizontal will follow this type of path. So we consider two independent axes. One is the vertical axis, that is the axis which is perpendicular, and another is the horizontal axis, that is the x-axis. So we will again express the motion of this type of projectile, which might be called as an oblique projectile. As two independent motion, one along the vertical direction and one along the horizontal direction. Again, as you know that the motion of the projectile is purely controlled by gravity. The gravitational force is acting in the vertical downward direction, whereas the motion along the horizontal is again a uniform motion, because along the horizontal there is no force, there is no external force. So the acceleration due to gravity is acting vertically downwards. So this velocity u vector will have two components, that is u cos theta along the horizontal and u sin theta along the vertical. U sin theta along the vertical. And g is acting along the vertically downward direction. So suppose the instantaneous position of the projectile is say P. P with coordinates x and y is the instantaneous position of the projectile. Instantaneous position means position at any time t. So this is obviously y and this is obviously x. So now you can see that along x-axis or along horizontal direction, along the positive direction of the x-axis, the motion is uniform. Along x direction or along the horizontal direction, motion is uniform. As motion is uniform, you can directly write distance equal to speed into time. So the distance covered in time t is u cos theta, because the velocity along the horizontal direction is u cos theta. So that is u cos theta times of t. And motion on the vertical is controlled by gravity. So along y direction, initially the motion is retarded until the projectile reaches its maximum height. Gravity is acting opposite to the motion, so it is partially retarded and then further it is accelerated. So along y direction we should say that the motion is non-uniform. Motion is non-uniform as the gravitational pull is acting along the vertical. So it is partly retarded and then accelerated. The first part of the journey up to the maximum height that it will achieve is partially retarded and then it is partially accelerated. So with respect to the instantaneous position, that is position at time t, remember that P is position at time t. Position at time t. And as such it is called as the instantaneous position. So if you consider the vertical motion, the displacement in time t is y, because this is y and this is x and this is y. So that is equal to ut plus half gt square. Velocity along the vertically upward direction is u sin theta, because acceleration due to gravity is acting opposite to the direction of motion. So it will produce a retardation, and so it will be minus half gt square. So from this equation 1 and this equation 2, we will replace time in this equation. So from 1 and 2, I can write y equal to u sin theta, sorry, it is ut minus half gt square, that is u sin theta into t, u sin theta into t minus half gt square. So this is u sin theta into t, t will be x by u cos theta, so this is x by u cos theta minus half g, t square will be x square by u square cos square theta, x square by u square cos square theta. So then this y will become sin theta by cos theta is tan theta, u will cancel out, it will become tan theta times of x minus g by 2 u square cos square theta, u square cos square theta into x square. So this will be the equation of the projectile, equation of the path followed by the projectile. So that is tan theta times of x minus g by 2 u square cos square theta into x square. Again, this is the equation of a parabola. This is again the equation of a parabola, but unlike the previous case, it is a bit different, but still it is the equation of a parabola, and as such we can say that the projectile is following a parabolic path, its locus is a parabola or its trajectory is parabolic in nature. So from here on we have to calculate certain things, that is the time of flight, that is how long was the projectile in air, what distance it has covered on the ground, what is the maximum height that is achieved. So these are the three things that we need to calculate. So we'll proceed with this equation. So let me omit the previous equations. So we'll keep this equation and we will proceed with the calculations of the maximum distance covered on ground, the maximum height, the time of flight, and so on. So let us start with the distance covered on ground. The distance covered on the ground is called as the horizontal range. This distance from the point of projection to this point, suppose this point is say M, this distance is called as the horizontal range, and it is called as or denoted as R. So this R is the horizontal range. Now we know that for vertically upward motion, this is what we wrote, y equal to u sin theta into t minus half gt square. So in this equation, if I take y is 0, what will happen if I take y as 0? Try to realize that when the projectile has started from the point O and it has reached the point M, its vertical displacement is 0. So when the projectile reaches point M, its vertical displacement is 0. Its vertical displacement is 0. But the time it takes is the time of flight, that is the time during which it is in air. The time it takes is the time of flight. Time of flight means the time during which the projectile is in air, and this time of flight can be written as capital T. So now in this equation we will substitute y as 0 because when the projectile has started its journey from the point 2 and ultimately reached the point M, its vertical displacement is 0. So in this equation we will write y as 0 and small t as capital T. So what we get is 0 equal to u sin theta into capital T minus half g capital T square. So now taking half gt square on the other side and cancelling t, we get half t is u sin theta. So it gives time of flight as 2u sin theta by g. So this is the formula for the time of flight, that is the time during which the projectile will be in air. If you remember purely vertical motion, in that case if an object is thrown vertically upwards, and it comes back, you see that total time is 2u by g, because in that case your theta will be 90 degree. For the vertically upward motion only, this theta will be 90 degree. So sin 90 is 1 and then that time of flight is 2u by g. So here just another factor, sin theta is being multiplied. So this is the formula for time of flight. So now we have to find horizontal range and the maximum height. So this maximum height, suppose this is called as maximum height h. Whenever the object reaches or achieves its maximum height, its vertical velocity becomes 0, because if the vertical velocity becomes 0, then only it can change its path and accelerate in the vertically downward direction. So when it reaches the point, suppose point n, that is the highest point of its trajectory, its vertical velocity becomes 0. So after calculating time of flight, we have to calculate r and h. So at the highest point of the trajectory, the vertical velocity is 0. Point of the trajectory, the vertical velocity, that is Vy, is 0, but Vx is same. So at this point the horizontal velocity remains constant, because along the horizontal there is no force. So the horizontal velocity remains constant but the vertical velocity is 0. So with respect to the vertical velocity, if I use the equation v square minus u square is 2as, so I will be writing Vy square minus initial velocity along the vertical is u sin theta whole square is 2 into, because g is acting opposite to the direction of motion, so this is 2 into minus g into the maximum height, that is h. And at this point this Vy is 0, so I will write u square sin square theta is 2gh after cancelling the negative sign from both the sides. So the maximum height will be u square sin square theta by 2g. So this is the formula for the maximum height. So now we have to calculate the horizontal range. So for the horizontal range, we have to consider the horizontal motion of the projectile. So along the horizontal there is no force, so it is purely uniform. So we can say that along the horizontal, after it has covered distance r, it has definitely reached the ground. That means along the horizontal you can say the distance traveled r, distance equal to speed into time. Speed is u cos theta, along the horizontal it is constant throughout, into the time. Now this time will be the time of flight, because after the time of flight it reaches the point M. So this will be into the time of flight. Already I have derived that the time of flight is 2u sin theta by g. So this becomes r equal to u by g into 2 sin theta cos theta. and 2 sin theta cos theta is sin 2 theta. So this is r, so this implies r is equal to 2 sin theta, sorry, this is cos theta, because there is a cos theta here. So 2 sin theta cos theta is sin 2 theta. So I get u into sin 2 theta by g. Sorry, u into u is u square. So this is u square sin 2 theta by g. U square sin 2 theta by g. That is the formula for horizontal range. So we have 3 independent equations, and from which we have derived 3 independent quantities. One is r equal to u square sin 2 theta by g. Remember, this is not sin square, this is sin 2 theta. H, or the maximum height, that was u square sin square theta by 2g, that we have already derived, and the time of flight we got 2u sin theta by g. So these equations are to be remembered for solving different numericals. Now we can also show that for 2 different angles, 2 different complementary angles, the value of the range remains the same. So if you find the maximum horizontal range, in that case we have to consider the value of theta. So if you remember, this was r square sin 2 theta by g. So when r is maximum when sin 2 theta is 1. If the value of sin 2 theta is 1, then only you can say that you get the maximum value of r, because the maximum value of sin 2 theta is 1. So sin 2 theta is 1, which means that sin 2 theta is pi by 2. It is sin pi by 2, which means 2 theta is pi by 2, or theta is pi by 4 radians, or you can say theta is 45 degree. So this means that if the angle of projection is 45 degree, the projectile will cover the maximum distance on the ground. And so athletes or javelin throw, the athlete who throw a javelin, they are trained to make the angle of projection as close as possible to 45 degree in order to achieve the maximum distance on the ground. So therefore, this maximum value of the horizontal range will be u square by g, and that happens when theta is 45 degree. Then theta is 45 degree. We can also show that for 2 different angles of projection, we will get the same value of the range. So again, starting from this equation, if you note that this equation can be written in a slightly different manner. So I can write here u square, because I know that sin pi minus theta is sin theta. So I can write it as sin pi minus 2 theta, because sin pi minus an angle is equal to sine of the same angle. So now we can write this as sine twice of pi by 2 minus theta. So this is the same form as that of the starting equation. If this is u square sine 2 theta by g, this is u square sine twice of pi by 2 minus theta by g. Now this means that there is some different angle theta dash for which we get the same range, and this theta dash is obviously pi by 2 minus theta. So you can say that for 2 different angles of projection we get the same range. So for 2 different angles of projection, theta and pi by 2 minus theta, we get the same range. the same range or same value for r. And these angles are obviously complementary to each other. So if the angle of projection is 30 degree, the range that we get will be the same as if the angle of projection is 60 degree. So this is what we can understand about range, maximum height and time of flight. Now if you want to know the instantaneous velocity of the projectile, suppose we want to know the velocity of the projectile when it is at the point P. So the velocity is always tangential to a curved path. So this velocity vector will have two components, one is Vx and another is Vy. So at this point P, at the instantaneous position or the position at any time t, you can say, if you want to know what is the velocity, that we can also calculate. So velocity at time t is, suppose, v vector, and that can be written as Vx I hat plus Vy j hat, because we know that the unit vectors along x axis and y axis are respectively I hat and j hat. So now Vx is along the horizontal, because there is no force along the horizontal, the motion is purely uniform and it will be u cos theta. Whereas the motion along the vertical is partly retarded and partly accelerated. So as per this diagram, Vy will definitely decrease with time until it reaches the point n. Vy becomes 0, and from there on until it reaches point m, Vy increases. So for the motion up to the point n, Vy is definitely decreasing. That means it is a retarded motion. So Vy equal to u sin theta, V equal to u plus at. From that formula we are trying to analyze this. For vertically upward motion, g has to be taken as negative. So V equal to u plus at. From that formula I can write it. So therefore you can say that the magnitude of the velocity will be Vx square plus Vy square, that is u square cos square theta plus u sin theta minus gt whole square root of this one. So this will be the instantaneous velocity. U sin theta minus gt whole square. And if you want to know the direction of this velocity vector, that also we can do. Suppose we assume that the angle made by the velocity vector with the horizontal is alpha. So here I can write tan alpha is Vy by Vx, which means alpha equal to tan inverse of Vy is u sin theta minus gt by Vx, which is u cos theta. So this is the way of representing the velocity at any point at any time t, and direction that the velocity vector makes with the horizontal. This is u sin theta minus gt. So this is the direction made by the velocity vector with the horizontal, and this is the magnitude of the velocity vector at any instant of time t.